Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my students all over the world. I hope you are doing well with mathematics, and we are doing this book. As you all know that we are doing this book and working on it, and we are at chapter number 3, which is lines, angles and shapes. So far we have covered angles in chapter 3, and we have tried to recognize the angles: acute angles, obtuse angle, right angle, reflex angle, and many more. Straight angles, revolution. In 3.1 exercise, we have also done such sort of things. Now in exercise number 3, exercise number 3.2, what we are going, there are some 6 parts in exercise 3.2, which are very easy. I'm going to tell you only 2 or 3 out of them, and we'll then proceed to our next topic, which is angle relationship, which is very much important, very much important. Mind it, boys and girls, this is very important, angle relationship. Now I'll just go through exercise 3.2. Okay. Now 3.2, use ruler and protractor to accurately draw the following angles. Now we have to draw some angles. I'll be doing some 3 out of 6. So A is angle. What is angle? ABC. ABC is equal to 80 degree. So we have to uh, the access with a protractor and a ruler. My dear students, no dimensions are given, no measurements are given, except the measure angle is given, that is 80 degrees. So what we do, we just start from making an angle of 80 degree like this. Now this is ABC, and what we have to do is we fix this point as a vertex. Now this is vertex. Okay, this point must be vertex because this is in the middle over here. We'll use protractor to draw angle 80 degree over here. Now you see that my center point is at point B, and my zero is coinciding with this line. My zero is coinciding with this line over here. My center point is over here. We'll read 80 degree from the inner scale. This is the lower scale, and we'll just put a mark over here. Then what we do, we'll just join the 2 points very accurately like this, and our this side is C. You may extend it with your ruler. Now this angle is 80 degree. Now this angle is 80 degree. Okay, very easy question. Question number E. Question E. E is 210 degree, and the measures are KLM. In fact, uh, should be written like this: KLM is equal to 210 degree. So same is the procedure over here. So we'll start making KLM from here. Since L is in the middle, K is in the start, so we write K L over here. Okay. We'll measure the angle with this protector. Now here it comes 210 degree. It is 210 degree. The last is M. Now my dear students, the angle which has been formed is like this, and this is 210 degree. Now what if I don't have this protector? What if I don't have this protector? What will we do? We'll just extend this line. We'll just extend this line. Now you see that this KLN. Now KLN is 180 degree. Just subtract 180 degree from 210 degree. The result will be 30 degree. 30 degree. That means if we add 30 degree in 180 degree, it will become 210 degree. Suppose now we don't have this whole protector, whole one, so this is half, and we are only limited with 180 degrees. Now we have 180 degree over here. Okay, now you see that this is 180 degree. Now what we do, we'll mark 30 degree from 180 degree by putting the D in reverse like this. We'll put the D in reverse. Suppose this is a half D, and we'll put this at 180 degree mark. Now this is 180 degree mark, and we will mark here 30 degree, 10, 20 and 30. So this angle, now this angle will be 30 degree. So the whole angle becomes 210 degree. So I hope you would have understood the position. Now the last question which I am going to do from this exercise is 335 degree. JKL. JKL 335 degree. I'll do it with both the D's, demonstrate it to you. Now since this angle will come somewhere here, so I have to leave some space over here. So this is our JK. So I have to fix K. So J is over here. Now with the help of roundy, it is very easy to draw 335 degree. So yes students, now this is the right angle mark which is 270 degree. We'll proceed it towards 360 degree, and here we find 335 degree. Here we find 335 degree. You may not can see this. Now this angle is 335 degree. Which one? The one which I am going to mark with green is 300 and JKL. Now this is L. Now which angle is 335 degree? This angle is 335 degree. Now my dears, same is the case over here. If we don't have this one protector with us, so what will we do? We will just subtract 335 degrees from 360 degrees. So what will it become? 25 degree. Yes. Now what we do? We'll just draw this angle instead of this angle. Now suppose we don't have this D, this one, we have only this half D. So what we will find here is this angle, which is the angle X. We will find this angle X. Okay. Now X angle is, put the D in this downward direction and we'll mark 25 degree out of it. 10, 20 and 25. Now this is the same angle, 25 degree. Now X is equal to 25 degree. X is equal to 25 degree. Since F is equal to 25 degree, we'll then minus it. We'll then subtract it from 360 degree. Our required angle will become as 335 degree. Our required angle, which was this one, will become as 335 degree. So this was all in exercise 3.2. Dear students, 3.2 was only that which I have told you. I have solved 3 out of 6 questions. Now we are proceeding and towards the our next topic, which I told you is very important, and that is angle relationship, or simply you can say it as angle relationship. So I'll write it somewhere here. Angle, if it is visible to you, angle relationship. Now dear students, you see that there are two figures drawn before you on the whiteboard, and that are, this is a right angle, as you know. This is a right angle, and right angle measures 90 degree. Okay, right angle measures 90 degree in total. Now this angle in total is 90 degree. You can also give the names to it, just as A, B, C and D. Now angle ABC is equal to 90 degree. Angle ABC is 90 degree. Okay. Now you see that there is another angle, which is, there are in fact two other angles, which are one, this one. So there are two angles. Now this angle ABD, angle ABD and angle DBC, angle, or you can say it CBD, whatsoever you want to, DBC, DBC. Now you can see that these two angles are within 90 degree, or you can simply say it that the summation of these two angles, the summation of these two angles is equal to 90 degree. Let me more elaborate it to you that this is angle A, this one, angle A, and this is angle B. The red is angle B. The green is angle A, and now this is angle B and this is angle A. Okay, if I add these two angles, A and B, just as I told you, if I add this, it will come up with 90 degree. So if I add A plus B, that will become as 90 degree. 90 degree. A plus B, that will become 90 degree. Similarly, if you add A, B, D and D, B, C, it will constitute 90 degree. So such angles which by submission come up with 90 degree are called complementary angles. Now these are called complementary angles. When two angles are when added when two angles when added gives the result 90 degree, then these are called complementary angles. Complementary angles. Now here you can also see some complementary angles. Now this is a rectangular. We have here some 90 degrees. Okay, all four angles are 90 degree. If I just mark this angle as x, now this angle is x and this angle is equal to y, then x plus y is equal to 90 degree. X plus y is equal to 90 degree. So my dear students, these are called complementary angles, and complementary angles are the angles in right angle which are up to 90 degree, and when the sum of two angles is equal to 90 degree, then we say that they are the complementary angles. Now dear students, again I have drawn two figures for you. Now you can see that when I say that this is a straight line, that means it is of 180 degree. Similarly here you can say that this is 180 degree. So like the complementary angles, there are also supplementary angles. What angles? Supplementary angles. There are also supplementary angles. Now what are the supplementary angles? If the sum of two angles become 180 degree, then they are called supplementary angles. When the sum of two angles become 180 degree, they are said to be supplementary angles. Now here you can see that angle A plus B, in fig 1. Now this fig is fig 1 and this is fig 2. So in fig 1, A plus B is equal to 180 degree. And similarly, in figure 2, x plus y r is equal to 180 degree. And this is the case then these two are the supplementary angles. A and B are the supplementary angles. X and Y are the supplementary angles. In just recap, what is a complementary angle? Now complementary angle was like this, A and B. Now these A and B were complementary angles. When added together, they become 90 degree, and these are the supplementary angle. When added together, come up with 180 degree. So these are called the supplementary angles. Now I'll tell you some of, there are two relations more left which are very easy again. Dear students, you can see three figures for here. These are the angles round the point. These are the angles round the point. If I write it here, angles round a point. Angles round a point. And when we say round a point, that means it has traveled one revolution, one complete revolution. And I told you very well that what is a revolution. When a point starts its journey from zero position, it travels to 90 degree, it travels to 270, it travels to 180 degree, it travels to 270 degree, finally it becomes 360 degree, it becomes one complete revolution. So this is one complete revolution, and one complete revolution is 360 degree. It is 360 degree cos it has traveled 90 degree over here, it has traveled 180 degree over here, 270 degree, and finally to 360 degree. So it has covered one complete revolution by covering 360 degrees. So this angle round a point is called one revolution, or the angle is 360 degree. When there are many angles like this, like there are angle A, B, C, or angle A, B, C, you can name at your own will, then that means that it has covered, now this angle has covered some distance, and from here to here it has again covered some distance, and from here to here it has covered back to its initial point. So the three angles, now the three angles has covered complete one revolution, that is 360 degree. That means A plus B plus C is equal to 360 degree. Again, now there are three angles. Now here are 1, 2, 3, 4, 5 angles. Now same is the case over here, that A, B, C, D, E accumulate, that B, C, D, E sum up, and when they sum up, they will give you 1 A plus B plus C plus D plus E is equal to 360 degree. Now this is equal to, this was only one angle, one complete revolution. There were three angles within 360, and there are five angles within 360. Therefore, when summed up, it becomes 360 degree. When this summed up, it becomes 360 degree. It was only one, so it is called one revolution. Dear students, now I have drawn three figures again for you. 1, 2, 3. And the definition of this is when two lines intersect each other at point. Now these two lines, you see this is one line, this is the other line. Now these are intersecting at this point. This is a common point. This is a common point. Now, what will be formed here? There are four angles formed, and the opposite angles will always be equal. Now, in the four angles, the pairs of angles are formed. Two pairs of angles are formed, which are called vertically opposite angles. Now, these are called vertically opposite angles. The dot angles are vertical, and these circular angles are also vertically opposite angles. Now, this is angle 1, this is angle 2. Angle 2 is vertically opposite to angle 2. Let me write it for your convenience, that if this is A, this is B, but not B, it is A again, because I have told you that the vertically opposite angles are equal. Therefore, A will be equal to A, and B will be equal to B, and B will be equal to B. Angle B will be equal to angle B. When, now let me repeat it, when two pairs of lines, when two lines intersect each other at one point, two pairs of angles are formed, which are called vertically opposite angles, and vertically opposite angles are always equal. Vertically opposite angles are always equal. Just in figure 1 you can see that angle A is equal to angle A and angle B is equal to angle B. Now here in this, now angle X are marked. Now you see that angle X are marked here and angle Y are marked over here, like here A and B. Therefore, angle X is equal to angle X because these are vertically opposite, and Y is also equal to angle Y. X is equal to X in figure, in let me write it here in figure 2. In figure 2, angle X is equal to angle X and angle Y is equal to angle Y. I can write here angles as well. In figure 2, angle X is equal to angle X and angle Y is equal to angle Y, because the two lines are intersecting at one point and they have formed two pairs of angles which are vertically opposite, and vertically opposites angles are always equal. X is equal to X, Y is equal to Y, A is equal to A, B is equal to B, and here again Y is equal to Y and X is equal to X. And to tell you that, you see, there's an interesting thing over here, that just suppose ignore this side. You see that there are only two angles, X and Y. Now what is X and Y? These are the complementary angles. You just see that this is a straight line, this is 0, 180 degree. So angle X plus Y should be equal to 180 degree. Similarly, these two angles, if you hide this side, X and Y will be equal to 180 degree. Therefore, it means that X plus Y angle, X and Y angles are complementary to each other, and here again complementary to each other. A and B are complementary to each other, and A and B are complementary to each other. And if you just add the whole, it will become 360 degree. So my dear students, I think this is all for today, and we'll be learning some more things in exercise number 3.3, upcoming exercise 3.3. So it's time to say you goodbye. Allah Hafiz.